ESS, Biodiversity Conservation Part 10, has its focus on the details of how to protect species and ecosystems, with special emphasis on how to design parks or reserves. The essential ideas are the impact of losing biodiversity drives conservation efforts, and there are various approaches to the conservation of biodiversity, each with associated strengths and limitations. Here is the outline for all of the biodiversity conservation movies. Use this outline to find the movie you need for review purposes. This movie is focused here. What are the considerations when planning the design of a protected area? The size of the area, threatened species, location away from human influence. Are there other criteria? I want you to be thinking about the details of designing national parks or reserves that protect species and ecosystems. What are the considerations when planning the design of protected areas? Location, high species diversity, threatened species, away from human influence, aesthetic considerations. If you were hired to design a national park, what would be your design criteria? Would you want as large an area as possible? How large? Would your park be round or rectangular? Would your park be located near to other parks with connecting corridors? Would your park have a central core area off limits to any human influence, surrounded by buffer zones or transition zones that would include tourists? What would be your design criteria? Would you choose unique habitats with high species diversity? Diversity could be defined as richness or endemism. Richness is the number of different species, and endemism is the number of species unique to the location. There are locations in the world that have never been disturbed. Are these areas that require protection? Would you start your design of a national park with the selection of location worthy of protection? Or would you choose locations that are threatened, as can be seen in this image? Or would you choose locations far away from the sphere of human influence? Are there locations far away from the sphere of human influence? So here are the two IB syllabus statements that will drive this movie to its end. Describe the considerations in locating habitats in need of protection. Explain the criteria for consideration when designing protected areas, and include the following in your discussion: size, shape, edge effects, corridors, and proximity to potential human influence. In addition to the criteria of size, shape, edge effects, corridors, and proximity to potential human influence, one must choose location well, and one must consider the relationship of conservation with local communities. Costa Rica, shown in this map, has a higher percentage of its total land area that's under protection than any other country in the world, at 25%. Look carefully. Some reserves are larger than others. Some have shapes that reduce the edge of the reserve, and some are located quite near to other reserves. So let me outline the considerations for park design in greater detail. This slide outlines the rest of the movie, and I'll go section by section. The considerations are, first, location, far from human influence, habitat diversity or species diversity, and rare, fragile, or threatened locations, ecosystems. Second, design criteria. Size, bigger is better. Shape and the edge effects. I'll speak more about this in detail later on. Corridors, between reserves, and core buffer zone design to the national park. And third, lastly, relationships with the community. Okay, with the next slide, we'll start with location. So let's look specifically at location. We should consider locations far from human influence, locations of high diversity, high overall habitat diversity, or high species diversity, and we should look at hotspots where there are rare species, fragile habitats, or ecosystems under threat. Here's a map of Peru, and you can see that the national parks in Peru are located well away from population centers, such as Lima, which has 9 million people. The majority of the 400-plus national parks in the United States, identified in red here, are located in the west-southwest, far from large population centers on the east or west coasts. Indian national parks are far from urban centers, or as far as possible, given the density of the people population in India at 1.2 billion people. Given the magnitude of the human population, what is the reality of our wild spaces on Earth? The reality is that our wild species exist on islands in a sea of people. Using this outline as a guide to our examination of location in designing protected areas, let's look at habitat diversity and species diversity. Rainforests have habitat diversity in terrestrial and aquatic habitats, not to mention various canopy layers. Tropical locations have a higher diversity than other latitudes, and vast tracts of rainforest further increase diversity because of the large area that they encompass. As well, tropical forests are mostly located in less economically developed countries, making them vulnerable to exploitation because of growing populations in LEDCs and because of the significant resources to be found in tropical forests. Look at all those trees. Now this should be another consideration in choosing the location for parks and reserves. And lastly, tropical forests also provide immense ecosystem services. This should be another consideration in choosing locations worthy of protection. Rainforests are warm and wet with high productivity, rich in resources, located in less economically developed countries. The diversity of rainforests is high, making them worthy of protection. Foliage height diversity increases the number of niches with canopy, substory, and floor. Rainforests can be mountainous, providing diversity in habitat by altitude. And rainforests have rivers and aquatic habitat in addition to the terrestrial. Forests with very tall trees provide many niches, micro-habitat diversity, thus greater species diversity, locations worthy of protection. Altitude change, as can be seen in this slide, results in habitat diversity and species diversity. Locations with dramatic altitude change would be worthy of protection. Kilimanjaro is located on the equator and rises to nearly 6,000 meters. The tropical location and the change in altitude makes the Kilimanjaro area worthy of protection. However, the park is relatively small at 1,000 square kilometers. Change of altitude, as can be seen here in northern India, where the Himalayas jump to over 8,000 meters, promotes diversity, habitat diversity, worthy of protection. There are parks scattered throughout the Himalayas, but population densities are putting pressure on fragile ecosystems. Population pressures, in combination with the high diversity, makes the Himalayas a hotspot for protection. Diversity of habitat, as can be seen in this photograph of desert in the foreground and snow-capped peaks in the background, increases species diversity. Regions with varied habitats are worthy of protection. And lastly, as we get under the hood of location, let's look at hotspots and rare species briefly. Locations that support small numbers of threatened species are worthy of protection. Hotspots are the very locations I've been referring to in the earlier slides. There are locations in the world that contain huge percentages of the world's diversity or endemic species or extremely rare species or rare ecosystems or threatened ecosystems. Any of these factors would qualify a location for hotspot designation and should factor into where reserves are planned and designed. Two IB syllabus statements that I've introduced to you in earlier movies, but are relevant to the considerations in designing areas that protect species and ecosystems are: quantification of biodiversity is important to conservation efforts so that areas of high biodiversity may be identified, explored, and appropriate conservation put in place where possible. Discuss the usefulness of providing numerical values of diversity to understanding the nature of biological communities and the conservation of biodiversity. Simpson's diversity index can be used to determine which systems are more diverse than others on the basis of the number of different species, species richness, and the relative abundance of those species, evenness. Ecosystem 2 is most diverse because it has 5 species, unlike ecosystem 1, and all 5 are equally abundant. Ecosystem 4 is least diverse because while it does have 5 species, 1 species dominates the ecosystem. The quantification of biodiversity is important to conservation efforts so that areas of high biodiversity may be identified, explored, and appropriate conservation put in place where possible. But remember that the term diversity might include the number of endemic species rather than just species richness, and conservation could focus on rare species regardless of ecosystem diversity. Scientific knowledge is available from intact ecosystems, knowledge that would assist conservation efforts. The use of data in assessing how conservation efforts should be applied is critically important because we do not have all the money or time necessary to conserve every species or every habitat. We can measure diversity, quantify diversity, and take important steps in conservation efforts so that areas of high biodiversity may be identified, explored, and appropriate conservation put into place where possible. The gathering of data, specifically quantifying diversity, allows us to assess changes to biodiversity over time as a means to assess the impact of people. These are satellite images of change over time in Lake Urmia in northwest Iran. Streams feeding the lake were being diverted for agriculture, reducing the inputs to the lake, changing the quantity and quality of the lake over time. The gathering of data, specifically quantifying diversity, allows us to assess changes to biodiversity over time as a means to assess the impact of people on ecosystems over time. So I'm using this outline to take you through the considerations for designing reserves that protect species and ecosystems. I've covered location in the previous slides, and now I'm on to design criteria: size, shape and edge effects, corridors, and the design of the park in terms of core and buffer zones. Here is the IB syllabus statement. Explain the criteria for consideration when designing protected areas include size, shape, edge effects, corridors, and proximity to potential human influence. The design criteria include area. We'll have the species area curve that I'll show you. The larger the area, the greater the diversity. And there's some thinking that 4,000 square kilometers is an area of an appropriate size. Anything smaller is too small. We'll look at shape. The edge effect needs to be minimized. The edge is disturbed and provides access to invasive species, including humans. And we'll look at one large versus many small parks. Edge to area ratio increases if one large area is broken into many small areas. I'll be showing you all of this in the slides to come. And more criteria: proximity to other reserves with corridors. This provides opportunities for colonization or recolonization if extinction has occurred. Also, proximity to other reserves and corridors provides for gene flow that increases genetic diversity. And lastly, clear design. Is there a core that's unvisited or off limits to anyone? Is there a buffer zone for research only and a buffer zone for tourism or education? Let's start with an examination of how area influences diversity. An increase in area increases diversity because the possibility of including rare species increases with increasing area. The relationship is simple and easy to remember, and at a certain size area, all species have been encountered, thus diversity plateaus. The bigger the area, the greater the diversity, and it's been suggested by scientists that parks should be no less than 4,000 square kilometers. Unfortunately, many parks in the world are not even this big, but there are parks that are 4,000 square kilometers or larger, and here is a list of some of the world's largest parks. Most of these parks are well away from human population centers, but places like Tsavo in Kenya or the Kalahari in Botswana would have villages surrounding the park. This is something you need to keep in mind. Of the 59 national parks in the United States, only 4 in the lower 48 states are larger than 4,000 square kilometers. They are Death Valley, Yellowstone, Everglades, and Grand Canyon. There are 7 parks in Alaska that are quite large. Now notice the shape of the parks. Those that are round have less edge to area relative to those that are long or slender in shape. The edge is the region where invasive species would have access, where people might intrude, where the natural ecosystem gives way to humans. More edge equals less diversity. Less edge equals greater diversity. Let's look at how the size of the park influences the quantity of park edge. The edge of reserves and parks is a region of vulnerability. More edge equals less diversity. Less edge equals greater diversity. In this diagram, I've calculated the edge to area ratio for a small area and for a large area. Here's the edge to area ratio for the larger park. You can see that the larger the area, the smaller the edge to area ratio. In designing parks or reserves, the bigger the better because the edge per area ratio is less. The edge is the region where invasive species would have access, where people with cattle might intrude, where the natural ecosystem gives way to humans. Reducing edge increases diversity. Costa Rica has 25% of its area in nature reserves or national parks, the largest proportion of any country. The largest park is La Amistad, which it shares with Panama. Now consider the importance of politics in sustaining a park that spans an international boundary. A park such as La Amistad presents a challenge in diplomacy if the park is to serve species and ecosystems. If parks must be small, having numerous parks adjacent to one another is important for gene flow among the species in different locations. So we've just looked at the importance of area in park design. Now let's look at park shape. A round shape relative to any other shape, if the area is the same, reduces the edge to area ratio. A round or square shape reduces the edge to area ratio relative to shapes that are long and slender. In this diagram, you can see 2 areas of equal area, 1,600 square kilometers. But if you sum the edges or calculate the perimeter, the shape with the greatest edge is the long, slender shape. As a note, conservationists will take any park of any size or shape. But if you have a choice in design, large, round, or square parks best serve species and ecosystems. Kanha National Park in Madhya Pradesh, India is 1,100 square kilometers. It protects tigers among other species. Notice the round or oval shape. This reduces the edge to area ratio. Shenandoah National Park in the United States has a long, slender shape following the spine of the Appalachian Mountains. The geography of the mountain ridgeline has determined the shape of the park. Shenandoah has a high edge to area ratio, but it's the shape of the mountains that determines the shape of the park. While reducing edge is ideal, people do the best they can to protect species and ecosystems. If a park or reserve must be long and slender due to the various constraints, so it is. Conservationists would happily applaud setting aside land anywhere, anyhow, no matter its size or shape. Mountain chains or barrier reefs, by virtue of geography, result in reserves with long, slender shapes. These shapes are not ideal because of the high edge to area ratio. Now let's look at another design consideration, one large park versus many small parks. You may already have some insight on this. Edge to area ratio increases if one large area is broken into many small areas. In this diagram, one large area of 5,000 square kilometers is compared with 5 smaller areas that have the same total area. Hopefully you could compare the edge to area ratio of these 2 scenarios. The one large area is more diverse than many small areas because the edge-to-area ratio is smaller here. So now let's look at the proximity to other reserves, or corridors. If parks can be located near to one another, then there are opportunities for colonization or recolonization if a species has gone extinct. Also, the possibility exists for gene flow that increases genetic diversity. In this diagram, I'm suggesting that proximity to other parks is important for gene flow and recolonization in case of extinction. As well, if corridors can be made and protected, gene flow is encouraged. An increase in gene flow between parks increases genetic diversity of individual species, important in their long-term evolutionary success. Here is a map of the state Madhya Pradesh in India, showing the location of 5 national parks, all of which support tigers. Are the parks close enough together to allow gene flow? Are there corridors between parks? There is talk of a corridor between Pench and Kanha, but India is a land of 1.3 billion people. These 5 parks are islands in a sea of people. Notice these parks here and here in Costa Rica. Had it been possible to create one large park instead of 5, 6, 7 small parks, that would have been ideal for increasing diversity. Nevertheless, these parks are close enough together such that they might encourage gene flow. If corridors between the parks could be made and protected, genetic diversity within species would be increased. And lastly, let's look at a clear design model with a core area that's unvisited for full protection of species, a buffer zone for research only, a buffer zone for tourism and education, and possibly a buffer zone for the sustainable harvesting of resources by local communities. So here's the idea. The core area is an unvisited area, off limits to people, left alone for the needs of the species within the park. The first buffer zone would allow scientific research. The second buffer zone would allow tourists. Tourist dollars would serve to sustain the costs of protection, guards, science, captive breeding efforts, etc. And possibly there is a transition zone for sustainable harvesting of resources by local communities. Parks and reserves created in less economically developed countries, LEDCs, could have more creative zones that serve to sustain both the wildlife and the local communities. This is a diagram of the World Biosphere Reserve. You can see the core, which is off limits to people. Surrounding the core, you have research and monitoring, as well as tourism. And in the third layer, the second buffer zone, there are communities who have access to resources that have been of traditional importance to those communities. Kanha National Park in Madhya Pradesh, India, has a core and a buffer zone. This is a park that supports tigers. Corbett National Park, Uttaranchal, India, has core and buffer zone. Corbett National Park also supports tigers. So far in this movie, we've looked at location and the design criteria, and lastly, we need to consider the relationship of the park and the local community. We need to monitor changes in biodiversity over time in order to assess the impact of local communities on the park. When planning a park or reserve, it's important to develop relationships with the local communities for the following reasons. The local community will provide protection of the reserve in the form of guards or patrols. The community must feel that the park area is worth more to them as an intact ecosystem than as an exploited ecosystem. The community must receive financial benefits. Encouraging local participation in park development is practical, economic, and political. Here's the IB syllabus statement. State that community support, adequate funding, and proper research influence the success of conservation efforts. We need to monitor change to biodiversity over time as a means to assess the impact of people. Local communities must feel that the intact ecosystem is worth more than the exploited ecosystem. Thus, to employ community people as guards, as guides, as scientists, and to ensure tourist dollars reach the hands of local communities, will help to sustain the park to maintain the long-term security of the biodiversity within the park. This is a photo I took of our guard in Bwindi National Park, Uganda. We were there to see gorillas. At the time, the cost for spending 1 hour with the gorillas was $375. I hope that my tourist dollars help support not only the guard, but the communities around Bwindi Park. Local communities need to feel that the gorillas are worth more alive than dead. If so, local communities will protect the park. And that brings us to the end of IBESS, Biodiversity and Conservation, Part 10.